Okay, today's September 22nd, 2011. We're doing lesson 1.4. We're going to be covering sine law. Okay? So sine law can be used for any non-right angle triangle. The law is stated as side of angle A divided by side A is equal to the sine of angle B divided by side B, which is also equal to the sine of angle C divided by side C. In order to use this law, you first have to know how to set up a triangle. Okay? So I've drawn a triangle down here. The uppercase letters are all representing angles. So I have angle A is here, angle B, and angle C. To get the corresponding sides, it will be whatever side is opposite of that angle. So you can name the triangle any which way you like. You can change angle A to be where angle C is and vice versa, as long as the opposite side is considered the opposite or the lowercase letter of that. So angle B, side B is opposite. Angle A, side A is opposite, and angle C, side C is opposite. Okay? So we're going to practice setting up a triangle in a minute. You're going to need to write down this law. You're going to need to know it for your test, sine law. And I give you a little hint because we're going to learn another law tomorrow. We're going to figure out when to use that one. You use sine law when you have the measurement of two angles in a row and a side, or when you have the measurement of an angle, then a side in between, then another angle. That's when we're going to be using sine law. Okay? We're going to get more into that. So make sure you copy down this page. This will be kind of like your reference page of when to use sine law. Okay, so in example 1, they've given us this triangle. We have an angle, another angle, and a side. Okay? First thing I'm going to do is I'm going to name this triangle. Now they've technically named it E, here's side E, D, side D, and F, side F. But I'm not going to use the letters they had. We're going to use our own letters. Okay? So remember what I told you? Our law was sine A divided by side A, sine of angle B divided by side B, and sine of angle C divided by side C. We're going to rename our triangle. Okay? So we're just going to choose any side or any angle to be a letter. So what do you guys want angle A to be? 95. You got to choose a side. There's no X here yet. So we're going to call this A, the 95 degree, which means what side will be side A? That's right. The opposite side will have to be side A now. All right. What do you guys want to call B? The unknown? Okay, Sampras, the unknown angle. That'll be our angle B. That makes this side B because it is opposite of it. And then we're left with C. This will be side C. Okay? So I know it looks confusing with all the arrows in it, so we'll just quickly redraw it with our letters. So, same thing. This is going to be 95, angle A, 38 centimeters is side A. This is our angle B. Angle C is 40 degrees. This is side B and side C. Okay? So we've set up this triangle. In order to use sine law, we actually have to have two opposite measurements. So we need to have a corresponding side and angle. That's the only way this will work. I need to have either both A's, both B's, or both C's. If I don't have any of those pairings, I actually can't use sine law. So if we look here, I actually have angle A and side A. So I know I can use my sine law. So I'm going to put it down. We'll rewrite the law again just so you guys get used to it. Okay, so angle A was 95 degrees and side A is 38 centimeters. So I have sine of 95 degrees divided by 38 centimeters. What other measurements do I have? Do I have angle B? Nope, don't know what it is. Do I have side B? Nope. And what about angle C?
Yeah, angle C, yeah.
What is it? And side C is? We don't have it. Okay, so if we look right now, that's supposed to be a B. If we look right now, we have one pairing, so that's all set up. I have no information on this one, and I have one of the sides, or sorry, one of the variables with our C. So what I'm going to do is, because I have two different types of equal signs in here, I'm going to drop off the part of the equation where I have no information. So I don't have any information on sine B, so I'm going to take that out of the equation, and I'm just going to set up this one to be equal to this one. So what I mean by that is I now have sine 95 over 38 is equal to sine 40 divided by side C. Okay, so now that I've dropped off the sine B, I have just one equal sign, and I need to solve for something. What do I need to solve for right now? C. It's the only variable I have in this entire equation. I have all of the other numbers. I have one variable, so I'm solving for side C. So I need to get side C by itself. When we set this up, I want you guys to remember to cross multiply.
Yeah.
We have two fractions, because this is a division sign. And it says that this fraction is technically equal to this fraction. Well, I don't want to be working in fractions. So when I cross multiply, I'm going to be moving the C over to this side of the equation. So this side of the equation will now be multiplied by C. I'm going to move 38 over to this side of the equation. So this side will now be multiplied by 38. So it's going to look like this. C times sine 95 is equal to 38 times sine 40. Now that I have that, I'm going to try to equate some things. We're going to figure out what 38 times sine 40 is. So 40 sine times 38, 24.42. So this is 24.42. I'm going to figure out what sine 95 is. 95 sine 0.996. 0.996. Okay. And I still have times C. So now that I have all of these numbers here, I still need to isolate for just C. That means I need to bring this 0.996 over to the other side. Since it's being multiplied by C, I'm going to need to divide both sides by that number to move it over. It's the same as just moving this over and dividing. Okay? If this part here confuses you, you don't actually need to write that in. When it moves over to the other side, we're going to have C is equal to 24.42 divided by 0.996. The reason I divide both sides is because these two cancel each other out. Okay? And here we go. Get the calculator here. 24.42 divided by 0.996. 24.51. 24.51. Okay, so we figured out that this side of the triangle is equal to 24.51 centimeters. Okay, example 2. They've given us this triangle and some measurements. Now, they've named the triangle already. They called the triangle X, Z, and Y. But again, we're going to be using our ratio, so I don't have to use the letters they've used. I'm going to rename the triangle my own way. So, I'm going to call 85, we're going to call that our angle A, which means this will be the opposite side, side A. I'm going to call 35 my B, and we're going to call angle C, side C. Now we have... Oh, thank you. Good eye. Okay, So we have our side B, side A, and side C, angle C. We have two angles given to us, angle A and B, and we have side C. The only thing is side C is in two types of measurements. We have 2 feet, 2 inches, which thanks to Patrick, we now know can be written like this also. This symbol here stands for feet. This stands for inches, in case you didn't know. That's a completely different system. Okay, so what we're going to do, instead of working with 2 feet, 2 inches, we're going to convert this to one measurement, either feet or inches. Okay? We're going to convert it to inches because we don't want to be working with a decimal. If we have feet, we're going to end up with a funny decimal. So we're going to go to inches. So 2 feet, each foot is equal to 12 inches. Okay? So if I have 2 feet, that means I have 24 inches plus the original 2 inches. Very good, guys. 26 inches. So C, I'm going to erase this now. Actually, no, I'll write it in red, just above. We're going to be working with 26 inches as side C. Okay? So now that we've done some conversion, I need to actually solve this triangle. So if you guys remember the sine law, we have sine angle A over side A equals sine angle B over side B equals sine angle C over side C. So let's start substituting things in. I have angle A, which is 85 degrees. So sine 85. Do I have side A? Nope. So we're just going to keep that as a variable. I have angle B, 35. Try to write clearer for you. Do we have side B? Do I have the measurement for side B? No. Good. Good to see you're awake. And angle C, do I have that measurement? We'll get to that in a second. I'll get you to answer that in a second. And side C is what? Side C is 26 inches. Now, if you guys remember, I said in order to use sine law, we have to have an angle and the opposite side measurement. Now, I don't have that for any of these, if you notice. None of the ratios are complete down here. I have a variable here, and a variable here. So I actually can't use sine law right now. Is there anything I can do to complete this, Eddie? How can I get angle C? And good. Okay, so Eddie remembered that all triangles add up to 180 degrees. So if I have two measurements of the triangle, I can for sure solve the third one. Okay? All of those angles, angle A, B, and C, we'll write it down here. So we're going to say angle A plus angle B plus angle C equals 180 degrees. And we knew that angle A was 85. Angle B was 35. And whoops, supposed to be a plus. And we don't know what angle C is, so this is the symbol I'll use. We'll call it X, okay? We say angle C is our X right now, is equal to 180. So I need to isolate X. I need to move 35 and 85 to the other side of the equation. So our angle C is going to be 180, subtract 85, subtract 35. Is that what it is? 90, 120. Yeah, it's 60. Good. So we now know that angle C over here, we solved for it, is just 60 degrees. That's what the angle is. But now I can plug it into the ratio here of my angle C. We know we can replace this now with 60 degrees. So now I have a complete ratio. I have both of these. And the question is asking us to solve for a different side. I want to solve for an angle. All right, so now that we have that information, I'm going to copy it and bring it down. So we have some room to work. Okay, So, now that we have that information, they're asking us to solve for both of the other sides. So they want us to solve for side A and side B. Now, I can't do this at the same time. I got to put pairs together. So I'm going to start with just solving for side B with this ratio. In other words, what that means is I'm going to cut this out of the equation to start. And I'm only going to work with these two. So my next line will read sine 35 is equal to B. Sorry, divided by B is equal to sine 60 divided by 26. Okay? Now remember I told you before, these are fractions technically. This is a division sign. This means divided by. And if I have two fractions equal to each other, I'm going to cross multiply. So I'm going to bring the B over to the other side. So this will become times B. I'm going to bring 26 over to the other side. So this becomes times 26. Okay? So we'll now have 26 times sine 35 is equal to sine 60 times B. Now, before I solved everything in the last example, I solved 26 times sine C, and I solved sine 60, and then I just moved the decimals. I'm going to do this one a little differently. You can pick and choose which one you want to do it with. I'm going to choose not to solve them yet, and I'm just going to move sine 60 over. It's still the exact same thing. It represents a decimal. Because this is times, I need to move this to the other side. So it's going to become divided by. Let's use a real side. So I'm going to divide this side by sine 60. The only difference is I just didn't solve for it yet.
Please come to the office.
So what this will read now is B is equal to 26 times sine 35 divided by sine 60. Now I can do all of these in one step if I like. Take out the calculator. We have sine 35 times 26. Oh, on my calculator I can't do this all at once. That's 14.91. So the top is 14.91 divided by, let's figure out what sine 60 is. 60 sine 0.866. 0.866 is equal to side B. And finally, 14.91 divided by 0.866, 17.21 is side B. So when we scroll all the way back up to the top, side B is what did we say? 17.21, okay? 17.21 what? Inches. We solve this in inches. Okay? So this is in inches. Make sure you get the right measurement. Okay? Even though it started in feet and inches, it's not 17 feet and 0.21 inches. This is 17.21 inches. And what I'm going to do is I'm going to round this because I actually want to convert back. Since that's a real life thing, we might have to go to Home Depot and they're only measured in feet. So I'm going to round this. We're going to say if I needed to actually do a measurement here, and I went to Home Depot and I needed to get the right amount of material, how much material would I need if I need 17.21, if they only go by the inch? Do I order 17 inches or do I order 18 inches? Why do I order 18? What if I only order 17? What's going to happen? We're going to be short. So I would order the 18 and then cut it. Use the excess. So let's say for some reason I am building something. We're going to say it's approximately 18, okay? Because if I went to Home Depot, I'd need 18. But again, they work in feet and inches. So how many feet, how many inches is this? Let's go down. See if you guys know this. So if I have 18 inches of something, how many feet are in an inch? 12. So I would divide 12 by 18. How many times does 12 go into 18? So 1 times 12 is 12. I subtract. What's left over? So,
Excuse me for the interruption. Can Max Knox please come down to the main office? Thank you.
okay. So we have 1 foot and the remainder is inches. So we said B is approximately 18 inches, which is also, from what we know, 1 foot and 6 inches of material. Okay? So we convert it back also. So we had quite a few things there. 2, 5, 16, 17. So homework is on page 31 and 30. Oh, sorry, 31 to 33. And you're doing numbers 2, 5, 16, and 17. Sine law, all of them.